Hello and welcome back for another VMK in the C++ series. In this video, I'm going to show you how to pass variables in and out of functions and basically how to use functions so that they can be useful inside of your programs. Let's open up Visual Studio and create a new project. So we'll just go New Project, and again we're going to choose Win32 Console Project. I'm going to name this guy Functions and click OK. Console application should be selected here, and when you click Finish you'll have your main program with nothing in it. Now the first thing that we're going to do is we're going to go into our class view over here, and when we open up our functions project you see that currently we only have our main function showing up. This is our entry point into our program when it first starts up. Now let's talk about functions. We can declare a function like so. Void, no param, open bracket, open brace, and then close brace. What I've done here is I've declared a function that's going to return nothing because there's a void right here, and it's going to accept no parameters because we don't have anything between these brackets right here. Inside of the function, what we're going to do is we're going to print f a statement to the screen, and I'm just going to display inside no param. I wanted this to be named param. No param function, like so. Now in our main function, what we can do is call our function that we just created by using its name, like so. So if we go and press Ctrl F5 to build this and run it, we can see that inside no param function is displayed to the screen, and then we press any key to continue. We can add in some extra carriage returns here just to make it a little bit clearer as to what is part of the function and what is not. So there we go. Inside no param function is displayed. If I go and call this function multiple times, like this, what we're going to have is inside no param function displayed to the screen 3 times. So by using a function, we can group different kinds of logic inside of here and have it be called anytime we want to call our function, like so. Now usually when you create a function, you'll want to either have the function return something for you or be able to accept some sort of input. And then based on the input, it will do some sort of task. So let me demonstrate. Let's get rid of this no param function, and we'll create an integer, I value. I'm going to give this value, let's say 5. What we're going to do is printf to the screen the current value stored inside that parameter. And actually, I'll write out here before. And I'll do another one here that's labeled after. And then in between these, I'm going to call a function which is going to accept our I value. And we can do this by, let's give this new function a name, 1 param value. And it's going to accept an integer, so we need to specify here int I value. The parameter name for the integer that gets passed in here does not necessarily have to be the same name that we're using here. It could be anything. So let me actually demonstrate that, and I'll change this to be IV. Inside of our function, what I'm going to do is I'm going to take IV and multiply it by 10, and then save it back into IV. Then inside of our function, I'm going to display how much that value is. So here I'm going to go %d and then comma IV. So what we're doing is we're taking 5, we should display 5 to the screen, we're passing 5 into our function, so we need to call the function here, and we pass in our value, which is I value. And then we're going to display this, and then after that we're going to go back out here, and then after is going to be displayed to the screen, and then the value as well. So let's see what this does. So we see we have our I value is equal to 5, Then it goes inside of our function, and then we takes 5, multiplies it by 10, so that gives 50, and then we display inside function 50. And then once we return from our function, we see we display the I value again, and this time it's displaying 5. So it's important to notice here what happens to our variable. It's 5 when it's outside of the function, and it's 10, or actually, sorry, it's 10 times 5 when it's inside of the function. So even though we're passing in our variable into our function, anytime we change the variable inside, it doesn't affect how that variable is affected outside of the function. When creating functions that require parameters like this, what you can do is you can actually define a default value that will be accepted inside of the parameters. And the way I would do this is something like so. I'd put an equal sign and then the value that I want to default to. So let's say my default value is 3. What this will do is it will let you call your function without a value. Or if you do pass in a value, then that's the value it will use. So let's go and run this program right now. You notice that the output is exactly the same that we had before, 5, 50, and 5. But now, what we can do is actually remove the parameter that we passed into here, and as soon as we do that, then the function accepts our default value, which was 3, and then multiplies that by 10, and then displays 30 to the screen. So that's the way default values work. If we don't have a default value, and we try to call our function without a parameter when it's expecting one, our code won't actually compile. You'll notice that we get an error message saying, one param value function does not take 0 arguments. So it's expecting an argument, which means it's expecting a value here, because in the definition we said we need to pass in an integer. So because this function here is expecting a variable, we need to pass in an integer value into that function so that the compiler won't complain to us. What I've demonstrated here is a technique to pass by value into our function. Now what this really means is any time that we call one param value, the function here, the value that gets passed in here is duplicated and saved inside of this variable here. This could be a problem if you're passing in structures into your functions. I showed you in a previous VMK that you can create structures that will hold multiple variables inside of them. So for instance, let's say you created a structure that was a player, and the player actually had 100 different kinds of parameters inside. Well, you can just define your parameter to be accepting in a player type, which is that structure that we created before, but anytime we call our one param value function here, it's going to make a copy of all 100 values and then pass it into our function here. There is a better way to handle this so that your program actually runs faster, because the copying process could take a long time to copy all 100 parameters from our value that was used here into the value that's used over here. And that's called passing by reference. So if we wanted to pass in by reference, let's rename this function now, pass by reference. What we're going to do is just add in an extra symbol here. This is the ampersand sign, and I place it right beside the variable name inside of the parameters here. Now notice what happens when I run my program. If I build this, oh, we're getting an error here because I renamed my function, so I need to rename the function call over here as well. Let's just put some extra spaces in here. Alright, Control F5, and notice now what happens. The value was 5, we displayed it before, and it's 5. We go inside of our function, so we pass in 5 here, we multiply the 5 by 10, and we get 50. So we display inside function 50. But now, when we return from the function, afterwards, the value is persisted. Whatever value was saved inside of our function here actually stays with us after we leave the function. So that's why we see afterwards, our value is still 50. The reason for this is because we didn't make a copy when we passed in the parameter into our function. Because we're using pass by reference now, we're actually working with the original variable, which is this one right here. So we update that variable by multiplying it by 10, and then when we exit our function, we're still using that exact same variable, so it has the previous value that we had inside of the function. This is a way that you can speed up your computer programs if you're using functions to pass in large structures. Also, this is handy if you want to have your functions return values for you. So you can see I'm passing in a value into our function, but the function is also returning a value to us through that same variable. If you know your function is only going to be returning one variable, or one value I should say, then what you can do is do the following. I'm going to again rename my function here to return one param. And I'm going to accept just a value here, and it's going to return a floating point number. Inside of the function, what I'm going to do is I'm going to define a floating point number, and I'm going to define this guy to be equal to the minus value of whatever's passed into us. Because I want this value to be returned from the function, we use the keyword return, and we pass in what value do we want to return. So I want to return this floating point number, so I give the name of that floating point number. Now let's go and use this new function. We have return one parameter, we're passing in our value in here, but we also want to save the value that gets returned from us. So over here we need to create a new variable, and because it's returning a float, we need to create a float, and I'm going to name it fReturned. So you can see now this function is going to return some number. We're going to save that inside of fReturned, and let's go and display it to the screen as well. So now you can see we have value of 5 that's before the function, 50 inside, and then afterwards our original value that we passed in is still 5 because we removed the reference. We're passing in as a value, not as a reference, but the return value is minus 50 because that's the value that is calculated inside of our function. We had 5 times 10, which is 50, and then we're taking 50 and multiplying it by minus 1 to give us the minus 50 out. If you want functions to return more than one value for you, you have a number of ways of doing that. One, you can create a structure and then return a structure which will contain your multiple values, or you can pass in by reference, and then all the values that you're passing in by reference, you can return values through those references out of the function so that you can use them down below. So those are the options that you have. You're not restricted to only using one variable when you're passing in values into a function. You can just add as many as you like using commas. So if I want to say the first parameter is going to be an integer, the second parameter could be a float, the third parameter could be a boolean, whatever you like so. But remember, as soon as you do this, then when you're passing in values inside of your function call, then you need to specify those extra parameters. Like so. You'll notice that, oh, I made a mistake. Redefinition formal parameter fv. Oh, I've declared fv more than once because I have it declared here, but I also have it declared right here. So let's get rid of our return, and then I can eliminate that guy. So now, oh, still, what's wrong now? Cannot convert right. Because now we're not returning anything, we cannot do this because our function does not return a value. So now let's try to compile this, and still it's not working here because, right, we're still printing our returned value, but we no longer have it. So let's get rid of this guy. Now is it going to work? There we go. Okay, so here's an example of how we can pass in more than one variable into a function. And I've specified that we're going to pass in an integer, a floating point number, and a boolean. And notice also, I don't have to create variables to be passed into functions. Most likely that's the way you're going to use them, but you can also hard code numbers directly into your function so that these numbers are the ones you're going to use inside of your function call. One thing I want to make note of here is if you do want to use the defaults for any of these parameters, you have to be careful. I can't make the default integer equal to 1, like this. If I try to do this and I compile, you'll notice I get an error message saying missing default parameter for parameter number 2 and parameter number 3. If I want the integer to be a default value, I have to put it last inside of the list, like so. C++ is picky this way. It basically specifies that defaults have to start from the right-hand side. So this integer will now have a default value, but these two will not have a default. So that means you will be able to call this function using 2 parameters or using 3. You have your choice. You can also make 2 defaults by doing something like this, or you can make all of them default by doing something like this. So those are the different options you can use with multiple parameters and defaulting values. Let's move on now. Let me show you how you can create a function that accepts an array of values. You've seen arrays in the previous VMK, so I'm just going to quickly create an array here. Let's say it's an array that holds 3 values. And I'm going to specify these 3 values to be equal to 1, 2, and 3. If I want to pass these variables into our function, we need to define a function like so. Because we're working with integers, we're going to specify integer, and you say that this is going to be a pointer to an integer. So I'm going to give it a name, pointer integer. I'm going to call it A for now. Now inside of our function, if we want to use that pointer, we can just go like this. Printf %d, 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 PIA 0, PIA 1, and PIA 2. And let me demonstrate what happens to the values before and after our function call. Let me just copy this just to be faster. This one we'll call after. And here we're going to call our function which accepts our array. And when we pass in our array, we don't need to pass in an address or anything like that. We just specify the variable name of our array, like so. Let's compile this. And let's go and try it out. We see before we have 1, 2, 3. Inside we have 1, 2, 3, and after we have 1, 2, 3. Well, we haven't changed the values inside here, so let's quickly go and make some modifications. For int I equals 0, I is less than 3, I plus plus, and we're going to take PIA and let's take it and multiply it by 2. Alright, let's try this out. You notice that because we're passing in as an array now, the values before are 1, 2, 3, inside of the function are 2, 4, 6, but after are also 2, 4, 6. These are basically the same thing that we got whenever we passed in by reference. And that's because we're really passing in a pointer, and a pointer means that our variables that we're using here are still the same variables that we've declared outside. So we're not passing in by value, we're passing in by reference. But the reference is an array that gets passed in here. Now let's talk about dynamic memory. Let's say we wanted to create some dynamic memory. So we'll create a pointer to an integer, like so. And we're going to call PIA, or PI3 value, new int, and we want 3 of them. You'll remember as soon as you declare anything using the new operator, at the end you should call delete. Because we're deleting an array, make sure you have your square brackets in place. And let's see here, we have PIA value. Again, we're going to declare them 1, 2, 3. We're going to display them to the screen, before and after. And we're also going to pass the value into our array. What we're getting here is exactly the same thing that we had previously with our regular array. But now we're passing in dynamic memory. Now the reason why I wanted to show you this is because you may think, well, what I'm doing here is I'm taking a pointer and I'm declaring some new memory and then I'm going to update it inside of this function or return it. Well, why not take all of this stuff and put it actually all inside of our function? Let me demonstrate how this would work. We're taking in PIA here, and you're going to say, okay, well, I want to create some new memory. Then I want to define it 1, 2, 3, multiply it by 2, and then display it to the screen. Okay. Afterwards, we should still have PIA because it's returning for us. So here we should see 2, 4, 6 on the screen, and then we're just going to delete. Notice what happens if we do this. Our program actually crashes. The reason why it's crashing is because we're not handling our memory correctly. Our memory pointer is declared outside of our function, but our memory is initialized inside. So we're running into a scope problem. This pointer does not have the proper scope to persist outward out of our function. For this to behave properly, the way that this program is intended to work, you'll need to pass in a reference to your pointer. And the way we can do that is, again, pass in the ampersand symbol right here. As soon as we do that, we compile and run our program. Now it's all fine. We've declared our memory inside, and we can go in and use it outside of our function and then still clean it up properly. This is not a very nice way to handle things, but you will notice that if you go through people's codes, sometimes this happens. So if this is the case, you'll have to know you need to be responsible for clearing up the memory that was created in here. This is not a very good way to program stuff because the user who's using these functions has to know ahead of time that this function is going to be creating memory, which you have to delete. Alright, so I just wanted to show you that in case you do come across it when you're looking at other people's code. I think that's all I wanted to show in this VMK, so hopefully there was something in here that was informative that you may not have known about functions. Functions are great to modularize your program, so basically you create one function to do a certain task and then you call it anytime you need that task done for you. So you can group your functionality into functions and then have nice clean code to be able to follow whenever you're looking at it later on in the future. Come back for the next video where I'll show you how to break up your code so that you have multiple projects all linking in together.